welcome to today's lessons. In today's lesson, we're going to be looking at changing circuit. Okay, your first topic for this term, you actually studied electric circuit, okay, or we call circuit diagram. In that diagram, we were able to identify the symbols for each component that make up a circuit, and you were also able to identify double cells and single cells. Right now, we're having a first example whereby Millie is building a simple circuit, and this is what she has done so far. All right, you already know this component right here now. Now, at this point, Millie is confused. Okay, she doesn't know what to do next. Why? Because there are two pieces of wire to complete the circuit, and you need just one to make use of. So she doesn't know if to use the thick one or the thin one. All right, so she now decided to try out each piece. That is, try the thick one and then try the thin one. Now, what do you think will happen when if she makes use of the thick one? What do you think will happen? And if she makes use of the thin one, what do you think will happen? Okay, by now I believe you now know that the thick wire will make the lamp burn up. Why? Because the thick wire has more area. Okay, it has more space for current to pass through the same time compared to the thin one. It's like a chain, which we've learned before concerning conductor. More current will flow through the thick one than the thin one, simply because the thick one has more area, and that will allow more current to flow through, and that will make up the bulb to burn up more. So after Millie experiment, she will prefer to use the thick wire so that her bulb will light up with more burn up energy. And there is another case. We have George. George decides to build a simple circuit to see whether the length of the wire connecting the component affects the brightness of the bulb. Here's the circuit he designed to test this. He designed the circuit, but in place of the switch, he now put a clip. So the clip is now acting as a switch. And then on the other end of the battery that's supposed to close the circuit, he placed a long wire on a meter rule. Now each mark in this wire you see has a cut where it can actually conduct electricity. That is, at the 5 cm mark, there's a conductor there attached to the wire. At the 10 cm mark, there's a conductor there attached to the wire. At the 15 cm mark, there's a conductor attached to the wire. So when you take this clip head or clip key and then clip it on the, or tack it on the mark, the bulb will light up. Okay, the question I want to ask you now is how or what will happen if he clips the wire to the 40 cm mark and then move it closer to the 5 cm mark? What do you think will happen if he starts clipping from 40 cm mark and then he keeps moving until he gets to 5 cm mark? Do you think the bulb will go dimmer or the bulb will go brighter? Okay, the bulb will go brighter. Yes. Why? Because the shorter the length, the shorter the distance the current will need to travel. All right, I want you to know today that when current is traveling through wires, especially in a simple circuit like this, they lose energy. This current you're talking about, you know, is electrical energy. Yes, it's electrical energy. As it's traveling, it uses some energy to do work in the case of movement, and this work we call it resistance. Okay, so work is done as a result of resistance of this material. When we say resistance of this material, we mean that we know we talk about conductors, metals are conductors, and we now rated the metals. We say silver is number 1 on the list, is it not? and then we have copper on the list as well, and then you also have what? Iron. Now, in arranging the list in our previous class, this is the reason why we arrange the list like that. Some materials, as current is passing through them, they lose energy. The current is reduced, that is, energy is lost as a result of the material, and this energy will call resistance. Okay, now the longer the material, the more the resistance, because the current will have to travel that distance. So as it's moving the clip head down from 40 to 5, the bulb will do what? We burn up more. That is, it becomes brighter and brighter. That's what I want you to understand here. Okay, what other way can we test whether the length of a wire makes a difference to the brightness of the bulb in a circuit? What other way do you think we can do this experiment or this simple technique? One other way we can do it, we can decide not to have a long meter rule. If we don't have a long meter rule, we just have a single long wire. We can just measure those wires and cut it on different length, is it not? Yes, if I cut it on different length, and then I attach and detach, we can also get the same result. Okay, another way we can do this is if we decide to use the lamp as our testing. That is, we position the lamp at different part of the wire. All right, what I mean is that I remove that wire that is attached to the other side of the lamp and make it more shorter, and then I use the lamp to touch different part of the wire. I will still have that result. Okay, I want you to watch this video to see how the length and the thickness or the area affect the flow of current. Pay in very important attention to what happens when the length is long and what happens when the area is big. Okay,
now if you look, I've got exactly the same circuit set up as last time. This time what we're doing, yes, we're keeping 4 volts, we aren't changing the thickness of the wire. What we're going to do is change the length of the wire. So I have a reading here and I have a reading here, and that is for when my meter rule is 100 centimeters of wire. If I take this out now, I break my circuit. If I then touch it on here, you will notice I've made my circuit again, only this time instead of a meter I have 90 centimeters of wire. So what I do at 90 centimeters of wire, I write down my current in amps, my potential difference in volts. The next part, I then move to 80 and I write down my new values. And then 70, 60 and 50. At each point you write down current and potential difference in volts. Once you get to here, stop. So that's when you have 20 centimeters of wire, and this prevents the wire getting too hot. So that's something that you record on your risk assessment sheet. Okay, so at least 5 different wire lengths with current and potential difference for each one.
Here's a comparison between 2 wires. That's a little bit thicker, the green one's a little bit thinner. Both of them are connected to the same side of this 12-volt plug. This wire is also thin, so that is also reducing the power. Listen to the sound, how much amperage can be drawn from a thin wire compared to a little bit thicker wire. So it will be more silent through this one and more noisy, the compressor, through this one. Silent and noisy. There's a thin wire That's a thicker wire, so it makes a large difference. Now I will replace both wires. The difference is not huge, thickness wise, but conductivity wise it is. That's a huge difference. So before only the right side, the plus, was blocking the current. Now both of them are conducting much better.
And welcome back from that video. By now I believe you now know that changing the thickness of a wire or the length of a wire affects the way the current travels around the circuit. And I believe you also know that we can use more than one test or one method to test the effect of length on a simple circuit lamp. Now that brings us to the end of this lesson. I want you to do your assignment as quick as possible, as I will be seeing you very soon, and we'll be talking about changing components. For now, stay safe.